Hello everyone, I'm Karen Hudson Edwards. I'm a professor in sustainable mining at the Camborne School of Mines and Environment and Sustainability Institute at the University of Exeter. And I'm here today to talk to you about some of my research on sustainable mining. This is my mobile phone. Like many of you, I use my phone for all sorts of applications, from reading the news in the morning, to playing the odd game, to finding my location. Mobile phones can do all kinds of amazing things, but to do those things, they require a lot of materials to make them. In fact, if you look at the periodic table, it takes 29 elements from the periodic table to make a mobile phone, which is incredible. You can think about some of the uses of materials. So copper is used for wiring, lead and tin are used for solder, and lithium is used for lithium-ion batteries. Well, where do we get hold of these elements that make mobile phones? We can't really grow them like we do with vegetables. So what can we do? Well, miners have a slogan, and it's this: if it can't be grown, it must be mined. So we need to recognize that mining is an essential industry to make our mobile phones. We wouldn't have them without it. Mining provides lots of benefits. Provides jobs for people, provides the goods and materials that we need, it makes infrastructure, it gives us scientific knowledge, and actually it can contribute to sustainable development. So it has lots of positive benefits. However, it's also true that mining has negative aspects. It can create pollution of water and air, can cause deforestation, it can reduce biodiversity in some places. And it also can impinge on human rights and human health and cause issues with safety if people are working in areas that are not good. It can also cause accidents like this. This is a YouTube video from a site in Brazil. So on the 25th of January in 2019, this tailings dam failed, and you can see that in the video. A tailings dam is a dam, a wall, that holds back the mine waste from the mine processing. And these wastes are called tailings. So it's the solid and the processing fluids that are stored. Sometimes these dams fail with catastrophic consequences. You can see this happened very quickly, and this wave of tailings created dust and wiped out some of the mine buildings. So unfortunately, 250 people were killed by this accident. It also contaminated about 200 kilometers of river downstream and wiped out about 133 hectares of Atlantic forest. Clearly, we don't want accidents like this. It's just not good, and it gives the mining industry a really bad reputation. So what can we do about this? Well, my research group and I, together with other colleagues around the world, do research on something called sustainable mining. We want to understand the impacts of past and present mining, like you see here, and we study that so that we can then help to understand how we can make things better in the future. Being based in Cornwall is a bonus for our group for lots of reasons. And one of them is that we have a historic mining landscape right on our doorstep that we can study. Mining in Cornwall has been carried out since the Bronze Age, we know. And so there's a lot of aspects we can study, from mine waste to the biodiversity and many, many other things. The other thing is that exploration is going on in Cornwall right now. So we can work with companies, governments, other bodies to help promote new mining and sustainable mining. So what is this thing called sustainable mining? Well, this summarizes it quite nicely. You can see economics on the right-hand side of the slide. To do mining, it has to be economic. The companies wouldn't do it otherwise. And the economies are good because, of course, they pay for the wages, they can bring wealth into a country, and so on. So that's kind of one of the main things. But it's being recognized that mining can be done economically by taking care of the other things that you see on this diagram. We can protect the environment from tailings dam failures like you just saw. We can stop pollution from happening. We can protect biodiversity, and we can respect human rights. So a lot of companies around the world are really making sustainable mining their paradigm and working towards it. We can also be more efficient with our resources. So we can mine more selectively. We can maybe go in and just take out the copper and not create any waste, ideally. And that's something that we're trying to move towards. We can also reuse our wastes. We can remine them from materials that were missed the first time round, or we can reuse the waste to make bricks and other things. Community is one of the biggest things in sustainable mining. We know that when we go into an area, the mining company might not live in this area. And so they should ideally engage with the community that lives there and will live there beyond the life of the mine. So the community should be involved with the mining right from the very beginning, right from the taking of the mining license through exploration, through extraction, and then to the end of the mine. Some people call this social license to operate, and it's being recognized that it's very difficult to get a mine going without that. And then finally, safety is something that mining companies do really try to take into account, but it should be paramount as well. We want to protect human health and also protect the health of the ecosystem and animals and plants that live around the mine. This is a site called Wheel Made in Cornwall. It's about 10 minutes from our Penryn campus. And so we take our students there on field trips often. And we also do research at this site. It's a really interesting site because it tells you a lot about Cornwall, aspects of Cornwall. In the background, you can see a couple of engine houses, especially one with the round tower sticking up. These are left over from the 18th and 19th century explosion in tin and copper mining. And this brought a lot of wealth to Cornwall and left a nice legacy of buildings and all sorts of mining artifacts around the surface. But we do have these areas where these mine wastes are left. Here we've got two types of mine waste. We have the orange solid waste, and we have the pool or the lake in the middle that has this fantastic red-orange color. That's called acid mine drainage. It's called that because it has a pH of about 2. It's acidic, obviously. You wouldn't want you to put your hand in it because it would really burn. The other thing about acid mine drainage is it can contain high concentrations of toxic elements like arsenic or lead or antimony that you definitely wouldn't want to be drinking. So we study this site to understand how acid mine drainage forms. If we can understand how it forms and what it's like, we should be able to treat it. That's the idea. And it's a good site to study because actually acid mine drainage is a global problem. It's probably one of the biggest problems that the mining industry faces because it's quite difficult to control and to remediate. So we can contribute quite a lot and teach our students about this at Wheel Made. So we also in our group do research on sustainable mining methods. And we take the knowledge of studying the natural environment and translate it to this. This is a bacterium. It's called Acetithiobacillus ferrooxidans. That means it can live in acidic environments and it oxidizes iron. And in fact, it's one of the bacteria that's involved with generating acid mine drainage. And that's where it's been isolated from. But we're using it in a project that's funded by the European Union, focused on developing improved methods of biomining or bioleaching. So what we do is we have some waste from a mine in Finland, and we are doing experiments in the lab where we drip sulfuric acid that's like acid mine drainage. We inoculate the heap with bacteria like Acetithiobacillus ferrooxidans, and these two components result in the minerals in the waste dissolving. And they can release small amounts or enough amounts of nickel, cobalt, and copper that can be recovered. Our partners in Finland are now taking our lab scale work and scaling it up to a pilot scale that will be used in industrial processes to recover additional nickel, copper, and cobalt. And this is a really good sustainable mining method. It is used around the world. We're trying to improve it with our experiments in the lab, but it leaves a small footprint on the Earth's surface. You can reuse the sulfuric acid in bacteria, and you already can do it on waste. And then the waste that you end up with can be used to make other products like cement and so on. So lots of these types of sustainable methods are being generated, and we're working on several of those. This is a cartoon called a geomodel, and it's a specific one to Cornwall. It's a Cornish circular economy geomodel, and it relates to another project that I'm involved in called Met for Tech. The tech part of that and the Met part refers to technology metals. These are metals like lithium, cobalt, copper that are used in what we call the green technologies, and computers like our mobile phones. So used in solar panels, wind turbines, electric cars, all the technologies we need to move towards a net zero carbon economy. Now, these have been mined in the past, but because we're developing more of these technologies, we need more of these metals. And so what our project is trying to do is to understand where we get those metals from, how we can mine them more sustainably, and then how we can make them into products that we can recycle more easily. And that's essentially the circular economy. How can you take things, use them how you need to, and then keep putting them back in the system without ending up with piles and piles of waste? So this is a cartoon of Cornwall. Cornwall is underlain by granites, as you can see, and decay of radioactive elements in the granites produce heat. That heat heats up the water that's within and around the granite, and it can move metals in the waters. They then go into those veins that you see there, and they can precipitate minerals that contain tin and copper, the things that are economic. They can also precipitate technology metals. So what we're doing in our geomodel experiment, our case study, is to work with local companies who are doing exploration for technology metals to try and work together to understand how we might mine more sustainably, how we can reuse waste. So I've got some wastes in yellow and orange on the surface. How we might mine marine deposits that I've got in pink there. And these tin deposits are left over. They're actually wastes from the placer mining that took place on the moors on Bodmin Moor and Dartmoor, mainly back in the medieval ages. And that mining wasn't terribly efficient, so a lot of the rivers silted up actually with tin. So there is a company looking at that as well. So we're hoping to take our geomodel and put onto it new sustainable methods, working with communities, making the law work to make things more sustainable, and putting this in a business framework. So as you can see, it's a great project, and it illustrates how sustainable mining works because we work with people from many different disciplines. And that's the best way that we can achieve this idea of sustainable mining and still getting the metals out of the ground that we need. So I'd like to thank you for watching, and I really hope you've enjoyed hearing about sustainable mining. Thanks.